I will let you take it away.
Okay, perfect. Thank you. All right, so welcome to my session on Cypher sleuthing. We're going to take a look at some of the things that I've learned and some tips and tricks for how to query a graph, things that might be different or things that at least kind of threw me for a loop when I was learning them. My name is Jennifer Reif. My contact information there is in the lower left-hand corner of the slide. It'll also be on the next slide and then the very last slide too. So if you don't catch it right now, don't worry about that. But this is going to be a really fun session with some live demo stuff. So I'm a developer and I really enjoy learning, which is probably a good thing for this type of field, as you do too, or you wouldn't be here. And then I enjoy sharing that learning, and that's part of what I'm here to do today. So I liked sharing that learning, whether that's through conference speaking or meetups or blogs or videos or any type of channel or medium that I can share that information or what I've learned or how I got there is a lot of fun for me. And I have a variety of hobbies. I love my cats and coffee and traveling and Star Wars and all those wonderful things. And so I had this nice long list and I was like, you know what, basically they all boil down to that I'm a geek and I kind of enjoy that. So I just kind of left that as my sum up of everything about me. So again, my contact information there. We do have a somewhat finite limited time here today. But if you think of something down the road, next week, tomorrow, 3 months from now, feel free to reach out to me. I'm more than happy to answer questions or continue conversation or help you along your journey or learn some more along my journey as well. So with that, let's kind of dive in. So why do we care about this topic? Why do we care about querying graphs or learning tips and tricks? How did this session really come about? Well, whether you're dealing with, Cypher, graphs, query languages, maybe you are working with that stuff now and you kind of wanted to get some insider information or some insights into how to improve, or maybe you're not doing anything with this. So what does that have to do with you? And really, this is all about documenting my journey about learning Cypher, learning graph. I'm relatively new to the graph and graph query language space, about 3 or 4-ish years now. But these lessons that I'm going to cover today, while I'm going to show and demo things that are very Cypher specific and graph specific for the most part, you can apply these skills to anything, whether you're adding skills or whether you just want to know a little bit about, graph or NoSQL. Those technologies are not going away by any stretch of the imagination. So why wouldn't you kind of pick up some information as you go? Helping to understand these data structures and then figuring out the query language logic, because as we'll see, it's different than even what I expected in some places, and learning that and understanding how it's working and why it's trying to do what it's doing is going to help us improve. So when you go about tackling a solution, if you don't really understand the language or what you're trying to achieve, you end up going about it with a trial and error approach. So you're really at the mercy of the language because you don't understand what it's trying to do or how it's trying to do it. And so you're just kind of, it's almost like whack-a-mole fixes, if you're familiar with that game. So you have a bug pop up. It's like, okay, I fixed that one. Okay, you have another bug pop up. Okay, I fixed that one. But what if instead of just approaching it as a very reactive type of approach, what if we could actually understand what's going on and what it's trying to do? That's going to help us bring mastery of the tool or the technology or the language. And then it helps us understand, by understanding when and how something is working, that gives us better efficiency, obviously, because if you understand something, you can find a solution faster and it's going to give you better results out the other side, because again, you understand what it's trying to do and you can manipulate that better. So first off, just to make sure everybody kind of has some background, because my examples are going to be using Cypher, let's just cover a few basics about the Cypher query language so that everybody's caught up and can follow along. So what is Cypher? It is a graph query language. It was created by Neo4j about 10 years ago. However, it is open sourced. I think that was back in 2015-ish, and it's very widely supported. So Neo4j is not the only vendor or graph by any stretch of the imagination that supports Cypher. There are several of them out there. Cypher is also part of the GQL or Graph Query Language Standardization. So kind of like you have SQL, GQL is going to be basically the same thing, but for graphs. And Neo4j and Cypher is part of that discussion and part of that standardization. You can find out more information at opencypher.org. That has some updated stuff on GQL, as well as just kind of the foundations of the language itself. So if you're interested, feel free to check that out. So what was Cypher created to do? What's its goal? It's really about following the path of connected data, helping to understand graph data patterns, surfacing those hidden connections, because traversing entities and relationships is not something that every query language does. And it's not something that sometimes those relationships aren't apparent unless you go out and search for them. And that's what Cypher is designed to do. So it's designed to traverse graph data in a database. So that's why it was built, to help performance for doing these kind of traversals, for uncovering data patterns in a graph. So let's take a look at some Cypher syntax. Cypher is both functional as well as visual. It was designed to store as well as retrieve data in a graph. It's based on ASCII art, so it does look very pretty, but don't be fooled. It's actually really powerful, has a lot of really cool functionality in there, and it's a declarative query language, which means that it focuses on what to retrieve and not how. So you don't write the language, say, this is how I want you to go about getting this data back. No, you say, this is the question that I want answered, or the data that I want to understand. And Cypher goes out and determines what the best way to get that data is. So we have an example, an image there on the right-hand side of this slide that is just a very simple graph. We have a node A or an entity A with a likes relationship to entity B. The Cypher statement right down below it there is match entity A likes entity B. And that's how we would query that pattern in the graph. So just some syntax stuff very, very quickly. This is literally Cypher in 20 seconds. So nodes are surrounded by parentheses. And if you bring parentheses together, you're going to get a circle, which is how nodes and entities are drawn in the graph, or kind of represented in the graph. And within those parentheses, then you have different things that pertain to the node. So you can have variables where you can reference that node later. Labels are kind of like categories or groupings for your entities, helps for query performance and visualization and that sort of thing. And then you can also have, as you see on the right-hand side there, inside the curly braces, you can have property keys and property values. So these are name value pairs, more metadata about the entities. So that's just nodes. Relationships kind of have that arrow sort of look to them with brackets. And again, you can use variables for relationships. You have a relationship type, which basically tells you what type of relationship or how two entities are connected or related to one another. Then you can also have property keys and values there inside curly braces for relationships as well. So that sounds like a lot, but basically Cypher is just looking for patterns of those two things. You're just looking for node, relationship, node, relationship, node. Of course, in different formats and different structures and different combinations and all sorts of things. But at the root, that's really what Cypher is trying to kind of show and demonstrate. Let's take a look at an example with the brackets and the relationship type in the middle. So we have two nodes and then the relationship kind of connecting them. And then within those nodes, within the parentheses, we have our labels, which again, kind of a category or grouping for your entity. So we're going to have one entity that's a person that belongs to the person group. And we're going to have one entity that belongs to a company group that we've created. And then we have some name value pairs or properties, metadata about these entities that say, okay, this person has a name of Jennifer, this company has a name of Neo4j. And of course, we could add all different types of properties and combinations and things like that, but we've just stuck to simple. So, okay, we've inserted this into the database. How would we go about retrieving this back out? So we do that with this statement here. We'd use the match keyword, which is a find or select. Then we know we have a node Jennifer. So again, our parentheses with our person label, name of Jennifer inside your curly braces for the property. We know there's a works for relationship coming from Jennifer to something else, but maybe we don't know who or what Jennifer works for. So we're going to put a variable called whom, and we just termed it whatever we want to, in this case, whom, inside the parentheses for that second node. And then we want to return all the details that the graph has about whom, about that variable. In this case, we know we're going to get Neo4j back because that's what we inserted into the database. And that's also what our image is showing here right up above it. So that's how then you insert data and then query it back out. Okay, so now let's actually dive into the good stuff, kind of the intricacies of some of the things I've learned about Cypher over the last year and a half or so. First up is the Cypher case statement. Now, if you're familiar with case statements in programming, you might think, oh, I got this, but so did I, and that's where the downfall was. So the pitfalls that I ran across is that I wanted to treat the Cypher case statement like a programming language, like Java. That's my background is in Java, programming language. And so I wanted to treat it like that. I wanted to do like variable setting or complex conditionals, a lot of data manipulation and things like that inside the case statement. But that's not actually how Cypher case works. Let me show you a couple of examples of queries that I actually wrote for the case statement that were indeed incorrect. So notice I have bad syntax comments as disclaimers up above these. Do not use the syntax, it won't work. So I have a CSV, or I had a CSV, and I wanted to create companies in my database. And if you've come across or dealt with a lot of data, especially in relational databases, you've probably seen where you have a single letter that denotes a more meaningful value. So for instance, a Y for yes or an N for no. In this case, I had a P for a public company, an R for a private company, and a G for a government company. And I wanted to make those more meaningful when I loaded them into the graph. And so, okay, when I'm creating a company, that's that merge company, the second line of the query. And then I go into my case statement. So for the row.type, which is coming off the CSV file, when that value is P, then I want to set row.type to public, basically set it for the CSV kind of variable as I've termed it. When it's R, then I want to set it to private. When it's G, I want to set it to government. Otherwise, I want to set that basically kind of column to other. And then I want to set a property in the graph, the c.businessType, to that row.type that I just got done setting in the case statement. Okay, that makes somewhat valid sense. If you look at the syntax on the right, it's very, very similar. Basically, all I've done differently is I've, instead of doing that row.type for the CSV column, I've just kind of created a new variable called type. So I've created and basically instantiated this variable called type and tried to set that to the more meaningful value. However, again, neither of these work. The reason is because I was trying to do programming language logic. Really, this is how the Cypher case statement actually works. So there's two different ways you can use it. One is you can compare expressions against multiple values. The second option is that you can compare multiple conditional statements. So first off, the first example, we're looking at people and their managers and the department that they're in. We want to find out, how do I contact a particular person? What's the best way to contact them? And so I'm evaluating the person's role. So return the person's name, case on their role. When their role is management, then I'm going to use the department phone. That should automatically go through to management, right? When their role is business, I want to use their business phone number for that individual person. When they're a technical resource, probably don't want to pick up the phone. You probably want to send them an email. So we're going to use that person's email address. Otherwise, just use the department email. You're bound to access, somebody that you need to, right? And so this is actually how you want to approach it. Notice in this case that I'm doing the logic and kind of the comparison during the when portion of the statement and not in the then portion of the statement. I'll go back and compare the previous slide here in just a second, but let's go ahead and look at example number 2 here. So multiple conditional statements. This one, I'm printing out a report of all my persons, and I want to see, okay, for all of my people in my database, are they, candidates, new hires, current employees, and then I also want to have a column that says, okay, when did we get them as a lead in our system? So here we're just matching persons. So pulling all of our persons, returning their name. Case, when the date hired property is null, then they're a candidate. When the date hired is greater than a year-ish ago, then they're a relatively new hire. Otherwise, they're just a regular employee. So they've been around for a while. Then I also want to do another case statement. When their date fired is null, then use the date hired as their lead date. When the date hired is null, then use the entry date into the system. So for instance, if they're a customer or something else. Otherwise, just say NA as their lead date. So again, I'm doing all of my logic, all of my comparison up in the when portion of the statement. And then I'm just doing almost a simple variable setting or a simple value in the then portion of the statement. Notice if you go back here, notice I was trying to do all of my logic in the then portion, which is what you typically do in a programming language. You do a simple evaluation and then you do some complex logic. And that's not the way that the query language, Cypher query language works when you're dealing with case. Okay, so let's actually take a look at this in person. I brought demos, so we're going to kind of flip back and forth here between the two. So I have a database up and running here. I have a Neo4j Aura, which is Aura DB, which is a Neo4j hosted cloud database. And this is a free instance. Everybody who signs up gets a free instance to kind of play with. Again, entirely Neo4j hosted, kind of fun. And so I've just kind of put some data into that, and we're going to demo with this. So what I've actually done is I've put the conference days for this week into the system. So here we have a Devoxx UK day. And let's say we're going to, with the day, and then I'm going to collect the d.date as the days. And then I need to unwind days as day. And then with the, and then I can do case day. So I'm going to evaluate the day, or the date in this case. And so when we have a date of 2021, 11/01, which was yesterday, then we're going to say that was conference first day. When the date is what happens to be today, then this is the second day. Today is. And I could probably write this a whole lot fancier than what I'm doing. This is pretty manual, but I'm just sticking with the basics for today. Then that's workshop day. Else, because you always need to have an else, let's just say we're just going to party. If it's not one of those 3 days, it's just party days, right? As what to do. And I forgot, I need to throw this, end the case statement there, and then return the day and what to do. So if I run that, oh, goody. Oh, yeah, because I didn't include this. That's why. There we go. Okay, much better. So we have our dates. We have November 1st. Okay, that's conference first day. Second is conference second day. The third is the workshops. Okay, that looks pretty good. We've got our case statement. Again, I've done all the evaluation up in the when portion. If the date, if what we're evaluating, which is the Devoxx UK day, evaluates and this equals true, then it's this. If this equals true, then it's this, etc. So we're in pretty good shape there. We could also do something a little bit slightly different. We could say we want to set the time for the end of the second day, or for the end of the days. So, okay, we still keep our Devoxx UK day, still collect our dates. When the date is this, then the end time is going to be, I believe yesterday's end time was 6:45 p.m. And that is local time, London. And end time 5:35. And then on workshop day, you guys actually get out just a little bit early, which, hey, that's always nice. Okay, we'll set it at 6:40. Otherwise, we're going to say a natural end time conference most days starts at 9. So we'll just say, okay, naturally, 5 p.m. And we could even do set d dot, let's say, end time equal to, we're going to reterm this when, because it's not what to do now, it's when. And we'll do that. Okay, and so we could set the end time, return, and actually I could change this to d.date and d.end time to show what we just put into the system. Okay, so this is actually now we're setting, so we're adding this to the graph. I'm actually writing this to the database. So I'm setting based on this case statement, whatever the result is, that I'm going to set the time, the end time for that day. So if it's November 1st, which was yesterday, the end time was 6:45 for the whole conference to wrap up. For today, you're actually going to get free at 5:35. That's the end of the last session. And then on November 3rd, which is a workshop day, everything gets released at 4:40. And then if we had other days in there, it would just set an automatic time of 5 o'clock. Okay, so that looks pretty good. That's the case statement. Again, we're doing all of our evaluation, that kind of, Boolean, true, false, and expression evaluation, all in the when portion of the statement, and then doing simple kind of value setting in the then portion. Okay, so let's jump back in here. So again, just to kind of recap, the logic is you either compare values or you handle conditionals. It's not a programming language, so there's no variable setting or manipulation or lots of complex logic. And just kind of a couple of hints, things to keep in mind. Your logic is going to occur in the when clause. The then clause is going to have a simple single value there. So just kind of some things to kind of keep in mind, kind of a cheat sheet. All right, let's dive into Cypher temporals. This is always fun. Anytime you talk about dates and times and time zones and all that wonderful stuff, right? Cypher is no different. It's tricky too. So the things that I had trouble with was understanding really the date format and then how to get back and forth with that date format. So it uses a standard date format, ISO 8601. There are lots of other things that use that date format as well. The thing that's tricky about that format is there is a literal letter T, in the middle between your date and your time values. If you're coming from maybe application or a GUI based or nice UIs or applications and stuff, you're probably not going to see a literal T. You're going to cut that out because it doesn't look pretty. But when you're dealing with the database, you have to have that in there. So therefore, there's lots of kind of manipulation and translations and adding this literal T in the middle. So that's kind of why I've termed it the pesky literal T. It's kind of a pain. And then we'll talk a little bit about durations, how to calculate durations. And within that, what gets tricky is understanding the precision and the grouping that goes into those. We'll talk a little bit more about that here shortly. Okay, so date format, again, nothing unusual here. It's the ISO 8601 standard, which means that your date format is going to be there right below. So 2021, so year, month, day, separated by dashes, and then date, time, year, dash, month, dash, day, and then notice that literal T. And then you have your hour, minute, second, and possibly any milliseconds if you want to, and your time zone at the end. So that literal T between your date and your time values is what can be tricky to add and subtract for viewing or database side stuff. I also want to quickly mention truncating temporals. This one kind of caught me off guard because when I came across truncate, I automatically thought of it like a database truncate, where, okay, if you want to truncate a date, you're chopping off a portion. So let's say, 2021, September 17th. If I truncate the date at the month, then I'm just going to get 2021 and September, right? Not true. So it's actually ghosting smaller units, so setting them back to defaults. This is helpful for generic searches or defaulting chunks of time. So looking for any dates that fall within the current year, looking for activity in a specific month. This is really helpful for that. We'll show an example of this so you guys can kind of see what this looks like. But any temporal type will accept the .truncate on it. So if you're dealing with a Neo4j temporal, you can add .truncate to any of them. So as an example here, we're grabbing today's date and returning date.truncate we're truncating at the month and passing in the date of today for that. So let's see all this stuff in action. We'll switch over and take a quick look. Switch over to... Oh, goody. It's not going to. There we go. Okay. So let's look at our date.truncate. So we have, let's just say date.truncate as today. Oops. Okay. I need to add. We're going to truncate it at the month. Oh, silly me. Yeah, what date is today? Return date.truncate. There we go. At month, and we're going to pass in today. And let's see what we get. Okay, so notice that today's date, so I could actually return the date as well. So you see, here's today's date, 2021, 11/02. And then if I truncate at the month, I'm going to get 2021, 11, which is exactly what we have over here, but it's going to default any smaller units than month. So if I had day, time, hour, minute, second, etc., it's going to default all of that stuff back to the first at midnight, etc. So I could do the same thing with, let's say, truncated at year, and it's going to go back to January 1st of 2021. Again, these smaller values are still there. We're just basically kind of setting them back to defaults or first examples. So let's actually take something fun here. Let's go back to our case statement. And we'll actually take this, okay, with truncate, and we're going to do at month, and then we're just going to use today's date as today, with today, case today, what to do, return. Okay, so let's start there. See if this works. Yep. Okay, cool. So what I did is I did a date, today's date, and I truncated it the month. So it's going to set it back to the first day of the month. And that's today. Although technically it's not, it's yesterday. We could make this better by just setting this to date. And then let's see, change that to date. Okay. So doing that, okay, on the first, guess what? That the first actually started the conference. So it's going to say, okay, that's the first day of the conference. So what if we truncated it then at year? Let's kind of change it up a little bit. So this will set it back to January 1st of 2021. Does anyone want to, fathom a guess at what the output is going to be? Because again, we've set our case statement and said, conference first day, second day workshop, otherwise party, which is probably what people are doing on January 1st anyway. But this shows you that then that case statement does actually work because if it doesn't hit any of those values, it's going to default to the else statement. And we've also covered our truncate statement because we've truncated at the year. So on January 1st of 2021, the conference was not going on. And so therefore our what to do is party. Okay, so with that, let's dive back over to our presentation and we'll jump into the next bit. So trying to get to ISO 8601, Cypher will accept the ISO 8601 date, so a temporal type in that format, or it will accept strings in an ISO 8601. But what if you have anything else, literally any other format? You're going to get an error. That's frustrating, right? This is where APOC comes to the rescue. So APOC is awesome procedures on Cypher. It's a utility library for Neo4j. It is very widely used. So lots of customers and Neo4j users use APOC. There's over 550. In fact, I think there might be over 600 or 650 procedures and functions in that library today. And I like to think of APOC as, if you're familiar with the game of chess, you can see there I have a queen chess piece there on my board. And I like to think of APOC as kind of the queen on the chessboard. So it can pretty much go anywhere, do anything, and kind of maneuver in and around things and take care of business that's needed. And that's basically what APOC is to Neo4j. Really super handy. If you haven't used APOC before, familiar with some Neo4j, definitely check that out. Super useful. All right, so if you're dealing with epoch time, this is a Unix system date or time. If you're dealing with processes or log files, things like Elasticsearch or timestamps on systems and things like that, you're probably going to be dealing with some form of epoch time. Epoch time counts the seconds since January 1st, 1970 at midnight, UTC time zone. So as an example, the end time for today's session, which local time is 10:20 a.m. for me, but it's 3:20 for London time, is that timestamp right there. So the 1635866 and I don't keep this around. If you kind of look at the bottom of my slide, I have a link there to an epochconverter.com website. That's what I use to kind of grab epoch time or switch back to human date stamps if I'm dealing with it. But if you're working within Cypher and Neo4j, you can handle these values and translate back and forth with apoc.date.format or apoc.date.to-ISO8601. So let's actually take a look at this now. So I'm going to copy paste this value here so that I have it. And then let's try to switch to my other tab, which of course is going to be fidgety on me. Come on. Bring back this window. There we go. Okay, so we're going to use this as a session end. And then we have our, what did I say? apoc.date.format. And I'm going to pass in session end. And you can store, or you can have epoch time in either seconds or in milliseconds. So if I switch over here and just take a quick look, here's our today's date, 10:20 a.m., which is my local time. And if I convert that to here's my epoch timestamp, which this is in seconds format. Notice that the epoch millis just adds a few digits onto the end. So you can do either one. I have this value currently in seconds. So I need to specify, hey, my epoch time is in second format. And then I want to put it into ISO 8601 time, right? So here I got to put that pesky literal T in the middle. Notice I had to put single quotes around it so it would read that. And then I can put my hour, :minute, :second. And then as, let's see, session end, or let's just say end. We'll just do that. Okay, so it did convert it. So it took my epoch time here and it converted it to 2021-11-02 with that literal T in the middle and 3:20 p.m., which is London local time. Now I could also do this, something similar with the apoc.date.to-ISO 8601. And then I don't need to specify this because it knows what ISO 8601 format is. And so then I'm going to get this value, which is again, mostly the same. The only thing is the standard 8601 uses milliseconds at the end here. So it adds milliseconds and the time zone as well. Now, again, you're getting strings output from this. Okay. So I'm taking epoch time, I'm converting it as a date string is what this ends up being here. Now, there is one other caveat I want to show as just an option. If you need to convert a bunch of formats or go to strings and stuff, that would be the way to go. But you actually can go straight to Neo4j with epoch time using, let's see, date time, pass in using a component, epoch seconds, passing in that session end value. And this is our temporal. And we actually get a Neo4j temporal. Notice it's not just a string, it's highlighted and has nice font and all that kind of stuff. Where down here, we're just getting a string output. This one's giving us a Neo4j temporal value out of it, and not just a string. So you can do it this way. I'm pretty sure it also takes milliseconds onto that as well. So you can use an epoch, I think it's millis or milliseconds as the component, pass in a millisecond epoch time, and get that conversion there as well. However, if you're doing lots of conversions back and forth, or you don't quite have epoch seconds, or dealing with something else, then APOC might be the way to go with that. Okay. Or if you need to convert it to a different type of string. So let's switch now, go back to our presentation, and we'll cover just a little bit more ground. So we saw that. So now we're going to talk about date strings, which is kind of where we segued just a second ago. So if you're dealing with a temporal string, you need to get to an ISO 8601 string and then convert to a Neo4j temporal, more than likely. Any type of temporal string, any specified format you have, that's fine. Neo4j can convert it using apoc.date.convert format. performant or apoc.temporal.toZoned.temporal. All right, let's take a look at this. Go back here so I can kind of keep my apoc.date.convert format. So we're dealing with a string. So let's do 2021, 02, and let's just do the end time for this session, UTC time, of course, as session end, and then return apoc.date.convert format. Yep, that was the right one. Session end, and we're going to specify here is the format that it is in, hour, minute, second, and I want it to go to ISO date time, like that, as this is a string that we're getting output. So we get our formatted time. Again, all that looks good. It's adding that T in the middle because I specified, hey, I want it to go to an ISO date time format here. So it will handle all of that for me and convert that. Now I could do something actually really similar. I wouldn't even have to have the proper formatting in here. I could do kind of the American style date, which is month, day. A lot of times we put slashes in ours. Month, day, year. We could even remove that. Apoc.date.convert format, session end. So we're in the month, day. Oops, need to add my slashes back. Here, slash, and then year. And then remove these. And I want it to go to an ISO date. So get rid of the time. And it handles that as well. And again, outputs it into that ISO 8601 date format that we need. So you can use a variety of formats, a variety of characters and kind of separators and things like that. And you can still convert that. Now, kind of going back, we can go also to the, I think it was the toZoned temporal, if I remember right. Yes, apoc.temporal.toZoned temporal. So let's grab that apoc.temporal.toZoned temporal, pass in the session end. And I do need to tell it what format it's in. And then actually this is going to be a temporal value that's going to get output. Okay, so notice all the, the font change and the highlighting and stuff. We're not dealing with a string anymore. It's going right to a Neo4j temporal value. So we have our date string. We tell it, here's the format that the current date string is in. And then I want you to output it to a Neo4j temporal value. And so it's going to do that because it understands that it needs to be an ISO 8601. Notice that it also does add the time zone onto the end, even though I haven't specified one. So you may need to do some conversions and stuff with your hours and things like that before you add this in to that. But this goes straight from a date string in any format straight to a Neo4j temporal value. Okay, so let's switch back to our presentation then. And we just saw that. Now let's talk a little bit about durations. So calculating durations in Cypher. The thing that was really tricky for me on this is not only do you have the literal T in between your kind of date and time, you're also going to have a literal P at the beginning of the whole value. Precision is a little bit tricky. It's handled in months, days, seconds. The reason for this is year value, hour value can change based on daylight savings time or leap years or any sort of factors. And so kind of the more precise kind of groupings or time values are your months, days, and seconds. So your duration values are going to look like the one there, the P1, etc. And then if you need to translate those, you can use some duration functions. So the between function in months, in days, and seconds. And we're going to take a look at that. So what we want to do is calculate some distance then of what we've covered so far. So let's take a look and pull back up my window here. Okay. So we want to calculate some distance. So we're going to say let's just set, we're going to stick to our typical here, 2021, 11:02. And so I can use this to kind of set some different things. We're going to stick with our, let's say, start time of the session, which is 9:30 a.m. UTC as session start. And we're going to say return duration dot between. So we're going to calculate a duration based on the session start and actually the current date time. So as it is right now. Okay, as so far. So this is everything that we have so far. This is how much, so from the session start until right now, this current second, this is how much time has passed. So we've got 20,000 some odd seconds. Isn't super valuable, right? Don't worry, we're actually going to translate this here in just a second, but this is what the durations look like. We can even go so far as to copy this up here, and let's change this to the first. So we're going to go back to the beginning of the conference. It started at 9 a.m. yesterday, so November 1st at 9 a.m. Local London time, and we're going to call this DevOps UK start. Between UK start and current date time. So this is how much time has passed. You have 1 day and 22,000 some odd seconds. Again, not super valuable, but you're getting into kind of the, when I mentioned precision and kind of groupings and conversions and things like that, this is what we're getting into. So let's go back now and cover a little bit more ground and kind of see what we need to do here. So this is where your duration functions come into play. You have in months, in days, in seconds. Most of your components that you're dealing with, so if you want to grab, the number of hours or the number of minutes or the number of days, you're going to deal with whole values only. It's going to completely chop and ignore remainders. There are a few components that I'll show on the next slide that specifically just cover the fractional values, but most of your components, your general components, don't do that. So if you get, let's say from yesterday at 9 a.m. to now it's a day and a few hours, but it's going to give you one whole day and then drop any remainder, any of those hours and everything into the seconds bucket. Okay, so if you want to convert between units, you're going to need to use a combination of the functions, the in months, in days, and seconds, and then the components, hours, weeks, etc. So for instance, you can see the component groups there in the screenshot below. So we have months component group, a days component group, and a seconds component group. And then you can access any of the components within each of those rows. But let's say you have a value in days. And you can easily translate that to weeks, no problem. But what if you want to translate that to months? That's when you're going to need to use the duration function in months to go up to the next component group. And then you can translate to months, years, quarters, or any of those components in that row. Hopefully that makes sense. But we'll see a couple examples to help kind of solidify that. So again, just a reminder, those three component groups, they're up at the top. And then I mentioned there are a few components that handle the fractions, and that's where that bottom screenshot comes in. So the quarters of year, months of year. So let's say you have, a number of 16 years and 3 months. You could use the dot years component and then also use the dot months of year component to get the 16 years, 3 months, that fractional value added onto that. All right, let's take a look at this in action then. So we'll go back to our demo over here. And so we can take let's just take our session start. Actually, that's not super valuable, but we can take the beginning of today. Yep. Okay. Session. Well, this would be day start. And then let's see, duration dot. So what we need to do is, well, I guess that won't give us a whole day though. I could still show this. Okay. So let's do in seconds, debating how detailed I really want to be here. And so we're going to do the day start, current date time. This is the content presented so far today. Now again, it's going to just pull seconds here. So we get this massive second value. This is how much time has passed since the start of the conference this morning. But then we could translate that and say, okay, we want to grab the components or the hours component of that. So again, since I'm in seconds, remember that seconds, hours, milliseconds, minutes, etc., all falls into that last seconds component group. And so I can pull any of those values. And so far, there are 6 hours of content that has been presented. Now I could fix this and go back to, since the start of the conference, I could do the in seconds. Yes, let's do that and grab the content presented so far. The number of hours has been 30 hours into the conference so far. And we could even go even just a little bit further here. Grab this. And we could use kind of that fractional value that I was talking about. And change this to minutes of hour. And so we have 30 hours since the start of the conference and 17 minutes in. So again, that's using that fractional value to capture those smaller units and help us pull that. We could also kind of translate this, okay, since the start of the conference, this actually isn't today's start, it's the start of DevOps UK, then we could do in days, days like that. Of course, we can't pull hours because that component is just in the seconds group. And you're just going to get 1 day as the outcome of that. And of course, if we had, let's say we could go all the way back to January 1st at 9 a.m., the number of days that have occurred so far is 305. And we could also pull, we could translate this and pull to the number of weeks. So we're in week 43, etc. So again, you can translate within your component group very easily. If you need to go outside of your component group, you need to use a function. So let's switch and drop back here, and we'll kind of wrap up temporals here. So the biggest thing really is to think through the format. What format are you starting from? What format do you want to end up? If you don't have an ISO 8601 format and you want to use Cypher or Neo4j, you'll need to translate that value somehow, either using Cypher or APOC to do it. To do duration calculations, you need to know your start and your end formats. So do I want, weeks? Do I want months? Am I starting with days? Do I want hours, etc.? Then determine the groups that you need. So what am I starting with? What am I ending with? Do I need to translate that? And then outline those translation steps. Which groups do I need to jump into? Which components do I need to access, etc.? So it's just a little bit of a thinking process up front. Once it makes sense, I don't actually think it's that complicated. It's just kind of tricky to kind of understand the steps there. Okay, so very quickly, some more APOC things is that you can output your date fields or your components as kind of like a map. And this is not something that Cypher currently does. So that's only available in APOC. The other thing is the 2 years, the apoc.date.2years function there on the lower example. That's something that the way that Cypher handles that is slightly different. I've got the Cypher comparison there on the last line of that query, and then the APOC one on the line above it. So APOC moves it to a float value where, again, Cypher cuts off that float value and calculates it just slightly differently. So there's just some things to keep in mind. Cypher may or may not offer that thing, and they may do it a little bit differently. Okay, last but not least, this is actually my favorite part, is the eager operator. What is eager loading? It helps keep consistency, avoid conflicts. All of your operations are going to occur to all rows before continuing. So this helps you avoid read-write conflicts. So you see the picture of the chessboard there on the right-hand side. It's kind of like pushing all of your chess pieces down the board together without leaving any behind. So to look at an example of this, if you're not doing eager and you're processing your data rows, it kind of falls through one row at a time. It's a row by row kind of process. So you take your first row, you drop it into operation 1, then you drop it into operation 2, drop it into operation 3, then you go back and get the next row and you do operation 1, 2, and then your result set at the end there. So again, row by row, where when you invoke eager, it's actually going to take all of your rows, drop them into the first operation, do the manipulation or whatever you need to do there, then drop them into the second operation, and then drop them into the result set. So it's an operation by operation approach rather than row by row. Does this really matter? Well, if you don't have a lot of memory or heap, if you're dealing with a really large data set, think thousands, millions of rows, again, trying to push all of your chess pieces down the board or all of your rows of data down through the query at once can really be very tricky when you're dealing with a lot of data. And if you're really, really concerned about query performance, eager might want to be something that you can optimize or help with. So let's take a quick look at this. I realize I'm very, very out of time here, but we're just going to take a brief look at how to do this. So I'm going to use profile, which is an insider or a kind of a handy little keyword inside Cypher that allows you to look at the query plan and what's actually going on in Cypher. So I'm just going to do something really simple here. Match devox day, return, let's just say d.date. Let's just return the date. So I'm just going to do a profile of that. So it pulls up. This is actually what Cypher's doing behind the scenes. I've got some other entities in my database, just so you know. So that's why that number is so high. But it's actually, you don't see anything eager here. But if I enact and add a count here at the end, count star, and run the profile on that, notice eager's popping up. Why in the world? All I did was add a count at the end. Well, what I've done is potentially by having a count at the end here, I'm doing an aggregation, which means if I toss one row through the query at a time, that count could change. It could be impacted, especially if I remove entities or change the graph or update some things. This count could be affected by anything that I do in the query. So therefore, because I'm doing an aggregation here at the end, it says, oh, wait, I don't want to impact and have read-write conflicts or bad results at the end. So I'm going to invoke eager and make sure that all the rows that are going through this query are getting pushed together. So that way we don't have data integrity issues. So that's what's happening there. And that's what occurs when eager gets invoked. Really simple thing, but it's tricky to notice and to get rid of. So really to avoid problems with eager, know your data. If you've got a massive amount of data or you're doing a lot of heavy processing like cleaning and operations, and you need to monitor that performance, watch for degrading performance, use profile or explain, which I'll talk about here in just a second at the end of the slide, and really keep an eye out for that and see if you can avoid it. To try to fix eager, or when you're not sure if something might be impacted, try to separate your operations out. So your reads, your writes, updates, try to split them out and put them into small pieces as much as you can. That helps avoid the conflict. And then use profile or explain, which profile actually runs the query and returns the plan for the query, where explain kind of does an estimation. So if you're dealing with a production database and you don't want to actually run the query in your production database, you can use explain and it'll do an estimation of what it's going to do and how it's going to do it. But if you're not concerned about that, use profile because that's obviously more accurate. Okay, so quick recap. We covered Cypher syntax today. We covered how to use case with Cypher. We talked about temporals and durations in the calculations, and then we talked about the lovely eager operator. If you guys are interested, I have all of this information probably in a lot more depth on my blog. Feel free to check that out. Also, all of the queries in the demo, you can recreate that. I've posted that out on my GitHub repository. And if you come across problems with Cypher or any other things, Neo4j related or case or eager or anything Cypher related, feel free to reach out on our forum. A lot of Neo4j experts hang out there and are happy to help you optimize or improve your queries. And again, my contact information is down there in the lower left-hand side. I'll pop onto the chat and answer questions. Thank you guys so much for watching. And